Hi y'all, welcome to lesson 6.1. This is kind of an addendum to the activity we did on Desmos the other day. So if you are not in our class, or if you didn't participate, or you were absent, or whatever reason, and you want more information about this work that we're doing in this lesson, feel free to pop into Khan Academy. There's lots of good resources there, or just sit down with me and I'm happy to go more in depth with you one-on-one. Let's start refreshing some of the vocabulary we will be using while we talk about circles, starting with our circumference, which is the perimeter of a circle. All circles have a designated center, which is the point that is equidistant from all points on that circumference, directly in that center. Moving from the center to the outside of the circumference is our radius. And then moving from one side of a circle through the center to the other side is our diameter. In our Desmos activity, we worked on deriving the formula for pi. How did pi come to be? And what we saw was that pi is the ratio of circumference and diameter. So for example, here we have a circle that has a measurement of diameter of 12 and a circumference of 37.7. When we set that up into a ratio and calculate 37.7 divided by 12, we get a rounded number that is 3.1416. Another example, if we have a circle whose diameter is 7.8 and its circumference is 24.5, we end up with that ratio of 3.1410. One more example, we've got diameter of 3.5, circumference of 11, which comes out to 3.1428. What we're really getting to is we can repeat this over and over, and we find that the ratio of circumference divided by diameter is actually pi. And here we're given a situation where we're asking, if we make a huge circle the size of a city and we measured that diameter and circumference, would the ratio of circumference and diameter be consistent with our other ratios that we've seen so far? And the answer is yes. All circles are similar figures, which that word similar is a math term. So similar can mean that all the measurements of similar figures are proportional to one another. So all circles are just enlarged or shrunken versions of each other. So no matter the size, no matter if we're talking about the circumference and diameter of Saturn or the circumference and diameter of a grain of sand, it will always be circumference divided by diameter is equal to pi. Always, always, always. And because we have this relationship where our circumference divided by our diameter equals pi, then we can use fact families and we can say, well, that means that if I take this and I do some algebra moves and I say, okay, I'm going to multiply both of these sides by d, what I end up with is circumference is equal to pi times your diameter. So this is where we get our formula for circumference in terms of diameter. And then because what a radius is half of a diameter, then it's also fair to say that that diameter is equal to twice a radius. So if we take our formula where circumference is equal to pi times diameter, replace this, we have circumference is equal to pi times 2r. And most typically, because multiplication is commutative, we write this as circumference equals 2 pi r. And it is actually most common when you are looking for the formula for circumference that you will see this in terms of radius. And that's because the definition of a circle is a set of points that are the same distance, aka the radius, away from a center point. So most often when we are talking about circles, we will be talking about it in terms of radius. All right, lastly, I'm going to be asking you to give me calculations that are exact, aka in terms of pi, and approximations, aka rounded usually to the nearest tenth or the nearest hundredth. So for these three circles, I want to show you what that means. So if we're looking for our circumference of circle A, we know our radius, so we would say that circumference is equal to 2 pi 0.5. So our exact in terms of pi circumference is equal to pi, because 2 times 0.5 is 1 and 1 times pi is just pi. Okay. The approximation then would be circumference is equal to 2 times 3.14, that's the most typical approximation for pi, times 0.5, which is just our circumference would be 3.14. I know it said nearest tenth, but I just can't write it as 3.1. I just can't do it. I'm sorry. The technical approximation would be 3.1 to the nearest tenth. Okay, go ahead and do these other two on your own. Give me an exact in terms of pi and an approximation to the nearest tenth, or if you're like me and that's too painful, go ahead and move to the hundredth. All right, there's a circle B. And I did a silly thing. I forgot to put my units on that first one, so don't forget those all-important units. Looking on centimeters for these first two. For that last one. All right, and there you have it for circle C. Go ahead and grab those journal problems and get yourself a PC. Thank you so much.